This is a video on the surface area of revolution. The question states, find the area of the surface formed by revolving the curve about the polar axis. And our curve is r equals a sine theta for theta between 0 and pi. So let's start by recalling the formula to find the surface area of revolution about a polar axis. And it states that the surface area S is equal to 2 pi times the integral from alpha to beta of f of theta times the sine of theta times the square root of f of theta squared plus f prime of theta squared d theta. Here, f of theta is just the right-hand side of our polar equation, or f of theta is a sine theta. F prime is the derivative. The derivative of the sine is just the cosine. So I get that f prime of theta is a times the cosine of theta. So now I just plug in, and I get 2 pi times the integral from 0 to pi of a sine theta times sine theta times the square root. F squared is a squared sine squared of theta, and f prime squared is a squared cosine squared of theta. And then I have d theta. So now let's simplify. A squared sine squared plus a squared cosine squared is just a squared. And I take a square root of that and I get a. So I can pull that a out with this other a and pull it out as an a squared. What I get is 2a squared pi times the integral from 0 to pi of sine squared of theta d theta. So I can use the half angle formula that says that sine squared of theta is 1/2 times 1 minus the cosine of 2 theta. The 1/2 and the 2 cancel, and I'm just left with a squared pi times the integral from 0 to pi of 1 minus the cosine of 2 theta d theta. The integral of 1 is just theta, and the integral of cosine of 2 theta, if I let u equal 2 theta, then du equals 2 d theta. So a half du equals d theta. So I pull the 1/2 out, and of course the integral of the cosine is just the sine. So I'm left with a squared pi times theta minus a half times sine of 2 theta from 0 to pi. If I plug in pi, I get theta minus 1/2 the sine of 2 pi. Sine of 2 pi is just 0, so I just get pi. And if I plug in 0, I get 0 minus 1/2 the sine of 0, and the sine of 0 is just 0. So all that's left is this pi that goes into the theta. So I get a squared pi squared, because pi times pi is pi squared. So the surface area of revolution for my polar curve is a squared pi squared. And I'm done with the problem.